Greetings and welcome, friends. Me and my buddies, we're just going over the homework right now. We were talking about shapes of distribution, and this asks the following. It says, the frequency tables show the number of entrees in a certain price range in dollars at two different restaurants. Display the data in a double histogram. Double histogram. Man, that's amazing. So let's do that. So there we go. I'll do something like that. I'm just gonna draw some lines, make little axes, double axes. So, right, something like that. And I want to make a double histogram. Ooh. Now, it's possible I could do like a back-to-back thing. Yeah. Is that what I should do? Should I do back-to-back? What are you guys thinking? Or no, top to bottom. Yeah. We did top to bottom last time. We'll do we'll do top to bottom. So watch this. What I'm going to do, I'm going to draw just another value, another row here. There we go. Now there's some slightly different interpretations you could do. So there's restaurant A, there's restaurant, I'll do restaurant B. I don't know. Restaurant B, bravo. Okay, so both of these will have the same price range x-axis scale. Looks like I gotta go from 8 to 25. So I'm just gonna call that 8, 11. I want these to be equally dispersed. 14. I'm just gonna put the starting value of each column. 17. Feel free to draw this down now if for some reason you didn't do your homework or you didn't remember or you got stumped on this one. That's fine. So I label my axis to some effect. Now, how high up do I need to go for these? 12's the highest on that one, and 8's the highest frequency on that one. So for my y-axis, it looks like I should 2, 4, 6, 8, 10, 12. And then I'll try the same thing up here. 2, 4, 6, 8. Right, so I'll label every other one. Okay, so for restaurant A, that's my top one here. The frequency is 5 for this first batch. All right, so I'm trying to line this up with that down there. You see that and that, right? You guys got it. You guys got it. Then I've got 9. Yeah. 9. Yep. Then I've got 12. Represent. Right, so notice I'm trying to line it up with its respective x-axis spacing. Then I've got, looks like 4. And then 3. And these getting wider slightly. And then 0. So that's a column of height 0. That's not very resante. Okay, so there's my histogram for restaurant A. Restaurant B, I've got 0. I can already tell you, I think restaurant B is more expensive. But maybe that's your style, right? Maybe that's what you want. Oh, but is it a waste, though? Maybe you're going to, like, propose to someone special at this restaurant. By the way, Waddy past story, I proposed to my wife at the top of Mount Monadnock February 13th, the day before Valentine's Day. We had to have, like, spikes and snowshoes and, like, pickaxes and stuff, ice axes, I guess, to, like, get up to the top. And then she said yes. Good news. All right, I know. Yep. And if she said no, then I would have been like, can I have my snowshoes back? Right, like, all right, bye. I guess I'll hike this way down. Thanks. It would have been sad. No, same car. Yeah. My car. If she said no, I don't know. She said yes, so yeah. So Waddy fans, yes, that's right. There is a Mrs. Waddy. out there. And she snowshoed up a mountain in February. Yeah. Eight and 6. Yeah, yeah. And coats. Yeah, it was cold. So guys, it says compare, my friends, the distributions using their shapes and appropriate measures of center. So, so this one, how would you describe its shape? It's a little bit symmetric. I know it's not exact. All right, here, hold down. You don't need to. Where this one, what would you call it? Ooh, good catch. Yeah, skewed left because the tail is longer on the left. Correct. So for each of these, I would use the mean to talk about any symmetric data set's measure of center. So the mean is probably somewhere around here. All right, so somewhere in the 14 to 17 category. And I would use the median to describe the distribution of a skewed graph. So I would use median, which is, I don't know, it's probably in the 20 to 23 family. Guessing. All right, these are just rough estimates. There are ways that you can retroactively make predictions, Kaylin, using this data, because I don't actually know where these land in the 8 to 10 range. I just know that there's 5 of them in the 8 to 10 range. Okay, so I could, let's say, pretend that these were at 9, Kaylin and Jake, $9 each. I could try to get a rough estimate of what a true mean would be, but I wouldn't ever actually know unless I had the original data. All right, as far as the measures of variation, we would have used standard deviation. Okay. For any symmetric graph, so I'd have, right, something like that. It's probably, I don't know, standard deviation is probably some number, something like that. And based on what we just did on our activity this morning, I would expect that about 68% would land within one standard deviation, and about 96% lands, or 95 even, percent lands between 2 standard deviations from the mean. I don't really know what that standard deviation would be. We'd have to calculate that. And top one, what? Well, this one. Well, the restaurant A, we would use the mean to describe the measure of center because it's symmetric. Right? Yep. Yep. And then this one, we would use the 5-number summary. 5-number summary. Okay. So that would end up being a box and whisker, which would probably look something like this. Right. I didn't quite do that. That's call it this way. Right, and since it's skewed, this side is going to be a lot longer. So we'd probably have something quite like that. So what is your comparison? What sort of facts might you say about these restaurants? If you're a restaurant reviewer and all you did was not taste the food, but you just talked about the standard deviations of the prices of food. Yeah. Why aren't there more statistically based restaurant reviews, you know? Really. Think about it. But yeah, what could you tell me about these restaurants? Compare them. Contrast them. Which one? Restaurant B is more expensive on average. All right. Average. Okay. Right, because it's probably on average between $20 and $30, $20 to $23. versus this one, which is more like $14 to $17. Okay, so it's going to be more expensive on average. Do either of these restaurants have a larger range of prices? I think both of them actually had a 0 height column on one end or the other. So the ranges actually ended up being the same. Yeah, so that doesn't necessarily say a lot. Although you could say that restaurant B, these what are these, entrees? Yeah, entree. Ooh, I get to put a little. Ooh, look at that. That's a fancy E right there. It's like wearing a hat. It's like it's out to dinner. No, I'm pretty sure it's an E with a hat. I'm an expert. I don't know. Accent, I've never heard of that. I'm pretty sure I'm right. No one's going to correct me in the comments below. Never. Nah, it's even like wearing its cap at an angle because it's hip. I'm pretty sure it like put a feather in its cap, called it macaroni. So let's see. Restaurant B's entrees are, let's see, densely packed towards its higher end. Towards the expensive end, I guess. All right. So yeah, not only is it more expensive on average, but notice that because of the way it's skewed, there a whole lot more of them land on the expensive side than even the cheaper ones that they do have. Right? That's a little bit trickier to see. Whereas these ones, they're evenly distributed, right? You know what your average is, and then it's going to be kind of the right what you would expect, a little bit above, a little bit below. Whereas these ones are going to be densely packed around the higher end because of the fact that it's skewed. All right, let's keep going. All right, the table shows the results of a survey taken that asked freshmen and sophomores how many songs they have downloaded on their MP3 players. It says make a double box and whisker plot. All right, guys, wow, this is great. We're doing all the doubles here. Wrong color for my graph. All right, so track with me here because you will have to do this on the test coming up soon. All right, box and whisker plot. I don't need a y-axis for my box and whisker plot. Let's see, what's my lowest score? Or my lowest number? The minimums are at 250. Yeah, that's the survey size. We might actually even call that N sometimes. That's the number of elements in my data set. So the minimum is 250. The maximum looks like 2400. So maybe I should count by 200s? You guys think? I think I'll fit it this way. Yeah, I should be halfway there. Kind of living on a prayer right here. You can do 500s if you want. That's fine. Let's see. Here we go. That's right. Smitty Werben Jaegerman Jensen. He was number 1. So let's see. For these freshman scores, the minimum was at 250. So I'll make this one at the top. So 250, that's about 250. No, I lied, guys. 250 is not halfway. I should be a quarter of the way between these two, correct? Because halfway between 200 and 400 is 300. So yeah, I had to quarter it. Good catch. Yikes. Let's see. The quartile one is at the 800. So I'm going to have a vertical line right there. The median was at 1200. Third quartile is at 1600. And the maximum was 2150. let's see, right here is 2100. 2150 would be a quarter of the way. 3/4, I guess, towards 2200. You guys agree with that? You see my logic? All right. Look at that box. All right, let's talk about the sophomores. All right, their minimum was at 360. So that should be about here. I'm guessing. Let's see, quartile 1 was 780. So that's going to be about there. This was at 800, 780 is going to be a little bit less. 2000 was their median. Oh my goodness. $2,200 was their quartile 3, and their maximum was 2,400. Did I grab the right one? 780, yeah. The median. Box and whiskers are always made up of medians. Sometimes, in fact, the median is also referred to as quartile 2. Yep, good question. So friendly friends, describe the shape of each distribution. Let's see, for my freshman, it looks like this is a little bit more symmetric. Right? It looks kind of like roughly a mirror of both sides. How would you describe this one? Now it's super dense over here. It's way spread out, and then it's a little bit dense again. But it's super, 50% of the data is in this super tight region. So I would call that graphically, if I was representing it, it might actually look like this. Some weird graph like that, but it's still most densely packed on this side. So it is skewed, and the tail was a little bit more on the left side, so skewed left. Yeah, well done. So let's see. We described the shape. Let's do some comparisons. It doesn't look like they asked us for it, or did I not copy part B of this? Oh, there's part B. Okay. Compare the number of songs downloaded by freshmen to the number of songs downloaded by sophomores. Who has more songs downloaded? Yeah, so for part B, yes, sophomores download more on average. Right? And as far as that average, the sophomore average would have been 2,000 compared to, what average would I use for the freshman? Now, that would be a convenient thing to compare it to, but because this is symmetric, we'll use the mean to compare it to. All right, so for as far as measures of center go, for symmetric graphs, we use the mean for a measure of center, and for skewed graphs, we use the median. All right? Let's see. So, yeah, so much more. Almost double, actually. About how many freshmen surveyed would you expect to have between 730 and 1570 songs? Okay. I already forgot. Was it 730 and 1570? How many would you expect to be between here? Why are you saying 50? Right. Yeah. Yep. So here's 25, here's 25, here's 25, 25. I lost a little bit over here, but I gained about that same amount over here. It's not perfect. It is an estimate. But yeah, I think 50 is great. So I would expect 50%. What if I asked you, so how many freshmen is that? How many people? Don't give me a percentage. Give me people. What could I do? Ooh, where'd you get that? Okay, perfect. Yes. So Kalen was saying that we should take the 0.5, multiply by the number of freshmen. That's excellent. Excellent intuition. That's inferential statistics, right? We took a percentage, we knew the population size, and now we're multiplying those to make a prediction of, so how many people are we talking, right? How many people are we talking? And you said, right, 22.5. But yeah, you said probably like 23 people. Yeah. All right, that's great. Did you guys catch that? I haven't showed you that. That's something that you just like intuitively knew. I love it. 23 peeps. And let's see, Delta, if you survey 100 more freshmen, about how many would you have expected to have downloaded between 310 and 1990 songs? Okay. Let's see. Okay. All right, what's another color I can use? This one. So 310. The 1990. So friends, how many, first of all, what percent do you think I've covered in this purple selection? All right, I've got an 80%, 82.5%. Would I be wrong if I said 50%? You could say, absolutely, I'm wrong. Right, there's definitely 50% here, so I couldn't somehow, in all of that space, I guess technically maybe what if all of the ones in this region landed there and there? But yeah, you would say, no, Mr. Waddy, you're wrong. That's just a bad guess. So it's most of the way. I might even say as much as like 90% maybe. Okay? But if I survey 100 more freshmen, what number of them, let's look at the phrasing, about how many would you expect to have downloaded between that? So if I have 100 new people that were not part of the original survey, how many people would I expect? I would take whichever percent that I liked. So yeah, 82, or I'll do it 0.825, multiply by the 100 people, and I'll get 82.5 people. So maybe I'd say 83. People are people. That's disrespectful to consider someone less of a person. Oh my goodness. I'm just kidding. It's all right. But yeah. So we can make predictions, right? So I've taken, look at this, out of a sample of 45 freshmen. Now I'm making predictions about a yet to be asked 100 freshmen. All right, and that's one of the benefits of statistics, is in real life, very rarely do we ever have all of the data, right? We don't, like when a survey's done, we don't get to survey 100% of humanity, right? We're never able to do that. That's just infeasible. We don't have the resources to do it. When we're making predictions about economics and poverty levels and all of these different things, or sickness and death rates or all sorts of stuff, I never have all of the data. But if I can get a portion of the data, I can make predictions about all of the data. In fact, little side story. Or yeah, what's your thought first? I believe there's like 212 freshmen in this right now. Somewhere around there. But one of the things I was going to say about perfect data is economists typically in real-world situations work with a portion of the data. They never have the actual dollars that everyone's made for every person in their nation. But in the last maybe even 5 to 10 years, video game companies have been hiring economists. All right, so in video games like that are made by Valve, so like when they started doing like the Team Fortress stuff, and you could buy hats or like cosmetic gear for your characters, that they actually hired economists to make predictions of how much can we charge for this, or how do we convert from our whatever Steam currency we have towards actual dollars, or economists working for the video game Eve, which is like a massively multiplayer kind of like sci-fi universe, that they actually had conversion rates to go from the in-game currency to real-world currency, and then they'd be able to make all sorts of predictions. And it was one of the first times that economists had perfect data, because it was in a video game setting. Their servers literally had the exact amount of money that every player had, or the rates that they were growing in currency at any given time. Comment, question. I own a PC that can play games, but most of the time I'm a console player. All right, well, thanks for watching, internet friends. That's right, Mr. Waddy is married and sometimes plays video games. Sometimes plays video games with Mrs. Waddy. Bye-bye.